All right, so we went over factoring and the quadratic equation. I'm going to go ahead and get started here. Make sure you have any questions on the problems on the screen right there. Those are to the end. Everybody have your graphing calculators when you need those. And then, does everybody have the other handout, that one that we had to go over with the benchmark? Now, Garrett, you needed it, right?
Yeah.
Okay. Did anybody else forget their handout with the benchmark? Just Garrett? All right, so on both sides. Okay. So it's printing right now. Make sure that you guys are doing the work that we are not finishing in class. Were there any questions on any of those? Did you check your answers? Yeah? All right. Any questions? Number 13? Okay. All right, so I'm going to do number 13. I'll be the only one I'm going to do. So everybody, let's go ahead and pause in, and we're going to go over number 13. Now there's two different ways that I've shown you guys the quadratic equation and factoring, okay? So now, what method did you try to use for this one? Quadratic equation? All right. Now be careful when you do the quadratic equation, everything has to be on the same side. So you notice you're going to have to move some terms around. Yeah. All right, so I need everybody to pause where you're at. You had plenty of time to do some work, so now let's pause, and everybody go to number 13, please. For this problem right here, the terms that are over here on the right side, we can either move everything to the right, or we can move everything to the left. What do you think would be the better move? If we move everything to the left, you notice you're going to have to plus 5k squared to both sides. When you do those, it's going to give you a positive 1k squared. And the negative 3 has to be a positive 3 added to both sides. Notice those terms cancel out completely. And all you're left with is a negative 8k plus 0 equal to 0. Once you do that and you get it equal to 0, that's the same as saying f of x. So this is 1k squared minus 8k f of x, or you could say y. Okay. Now, to do the quadratic equation on this one, ax squared plus bx plus c equal to 0. It's 1k squared minus 8k plus 0 equal to 0. Okay, let me have you stop what you're doing, please. You have plenty of time. I need you to focus up here now.
I'm working on this week.
Okay, let's pause. Okay, look at what I've done so far. Do you have any questions? This is where you need to make sure you're paying attention. Are there any questions on how I'm going to figure out the A, the B, and the C? Okay, let's A, B, and C.
A is 1k squared.
Not 1k squared. A is just the coefficient of that variable squared. What's B? Okay, let's see. Was that where you might have made a mistake? Yeah, okay. So now do you notice 0 technically, when you moved all the terms, the constants canceled out? So if you don't see that there's a constant there, a number that doesn't have a variable, it's because it's a +0. So don't feel like, oh, you can't plug in 0 into the quadratic equation. Okay? Now I am going to give you a hint. You can actually solve this problem faster if you try to do factoring. You can solve it faster factoring. Okay? I am going to do the quadratic equation though, okay? Please check to make sure I wrote this correctly. Did that look written correctly? Okay, let me have you pause. This is where I need you to let me know anything I'm doing is not right. Okay. All right, so I'm going to plug in these values into that equation. That's 0. Okay, take a look at that. Everything looks substituted correctly? Typically, if people mess up on the quadratic equations, most of the times at your guys' level, it's just because the substitution was done wrong. But if you remember the equation correctly, all you gotta do is just make sure you have it down in your notes. Okay. All right. That's typically at your guys' level. Where I've seen most people, if they do mess up, is just because they substitute maybe incorrectly or they forget something. Because at this point, your guys' algebra skills are pretty darn good. You guys know how to solve an equation. You guys know how to do PEMDAS. Yeah. You guys know how to graph. So sometimes they're just little simple things that might make mistakes for you. Okay. So does everybody see that the -8 is a +8 now? And we get a plus or minus square root of 64 minus 0. Everybody see that? 64 minus 0. Everything is all over 2. So you're basically left with 8 plus or minus square root of 64 over 2. Square root of 64 is 8. So that gives me two answers. 8 plus 8 divided by 2 and or 8 minus 8 divided by 2. And here's where I'm going to lose people. And this is why I say, okay, pause so you can see what I just did. All of this is supposed to equal x, yes? Okay. 8 plus 8 is 16, yes? 16 divided by 2 is 8. So one of the answers, or one of the solutions, the zeros, the roots, is 8. The other answer is 0. 8 minus 8 is 0, isn't it? Remember, 0 divided by anything is 0. It's when the zero's on the bottom that you can't do that division. And I'll show you this real quick. 0 divided by 2 looks like this when you first did division, when you guys were way back a long time ago. 2 times what will give me 0? Well, that's 0. And I'm left with the remainder of 0, right? But it's the other way around that you'll have trouble. 0 times what will give me 2? Nothing, because anything times 0 is 0. You won't be able to do this division ever. That's no solution. It's undefined. You can't do that problem. Yeah? So this is not, some of you, if you confuse those two, just make sure you understand the difference between those two. Because when we start going into some harder problems, we never want the denominator to be 0. And this kind of leads me to the problem I'm going to go to right now on the benchmark. It's a fraction that we're going to graph. We never want the fraction to ever be 0, so we have to find, is there any asymptotes? Okay. Do you guys see the work I did for this problem right here? Right?
How did you, how come you have to have two answers for this one?
Okay, good question. In the quadratic equation, that plus or minus right there, that's where 2 answers would be, unless, here are the 3 possibilities that can come out of this. If you get a negative number, you can't take the square roots of negative numbers, right? So negative numbers inside of here mean that there is no solutions. That means the graphs never touch the x-axis. Yeah? If you get a 0 inside of here, that means there's only one solution. Okay? If you get a positive number, then there's 2 solutions always. So do you notice we got a positive number? So if we would have got a negative number there, then that means this quadratic equation never touches the x-axis. Because you guys can't take square roots of negative numbers when you're graphing. So that's the part where, if I do get a positive number, that means there's going to be an addition of all those terms with that value, and then there's going to be a subtraction.
So what if there's a 0? That means that there will be
one solution, because square root of 0 is 0, which would just leave you with these 2 numbers to simplify. That's a good question.
So then that would equal 4 or something? Or would you just leave it as
oh, it would equal 4, yeah, because it would just be 8 divided by 2. So the only x-intercept would be at 4. If the inside of the square root was a 0, square root of 0 is 0. Don't freak out. You're like, oh, what? Square root of 0, I can't do it. No. Square root of 1, what's square root of 1? 1, just 1. Don't freak out with those 2 numbers, because sometimes people see 1s and 0s and they're like, shoot. What do I do? Square root of 0 is just 0. Yeah? Just remember square roots, 2 numbers that multiply together that are the same. 0 times 0. And 1 is 1 times 1. So those 2 numbers are kind of special numbers, 0 and 1. Very special numbers. Okay. So you guys see here what I put over here on the top right-hand corner? There's 3 possibilities that can happen. It can either never touch the x-axis, it can touch it once, or it can touch it twice. It all depends on whatever comes in here. So do you see, if you do make a mistake in here, that could change your whole answer? Because maybe you forgot a negative sign possibly? Yeah? If you forget a negative sign, that could easily change things, because do you notice there's a minus 4ac there? And if a and c are big numbers, and you forget that any one of those is not a negative, that might end up causing you to get a negative number. So that's typically where I've seen students at your guys' level. If they do make a mistake, it's just a little simple thing. It's not that they didn't know what they were doing. Okay? Any other questions? That was a good question. All right, you guys want to see the quick way that you could have solved this? Take a look at all the work I did for that one. Now, visually, some of you guys feel, okay, I understand that way better, yeah? But if I make a mistake, please let me know right now before I move forward, because I think that we did everything right, yes? Okay, but if I did make a mistake, you got to let me know right away. Let me show you the other way I could have solved this, okay? K squared minus 8k. Remember I got to this part, k squared minus 8k equal to 0? Check out this trick, so watch carefully. You saw that work I did right now? Here's where you guys got to visually look. Oh, man. Do you notice that these two terms have something in common?
Okay.
K. If I factor it out, that leaves me k times k minus a equal to 0. Here is my two parentheses that factored out to give me k squared minus 8k. Set each parenthesis equal to 0. One of the answers is k equals 0. You notice that was one of the answers. The other answer is k minus 8 equals 0. Wasn't the other answer k equals 8? Okay, which one did I get too fast?
Wow.
That one was faster, but maybe you didn't see that, right? So here's the thing is when you're doing problems, sometimes the quadratic is going to be faster. Sometimes factoring will be faster. It all depends on the problem. But you see the work I did for this is very minimal, and this is all justifiable. All I had to do was, here's a clue. If you ever get to that point and it's just the variables, there's no constant there, just do this. You'll get there faster. You notice the other one took me, 15 minutes to explain and go through, but you can probably do it in 5 or less. Yeah? Do you see that's not a lot of work? And remember that those numbers that you're getting are called your zeros, your roots, your solutions, your x-intercepts. All those things that I'm writing right there, that's what those two answers are. Yeah.
How do we know if that way will always work?
If this way will always work, because well, it all depends on the problem. It all depends on the problem. The reason, what I would say look for is, and I'll put a general term, ax squared plus bx plus c. If the c value is 0, meaning it's not there, and if the a value is 1, you notice the a value right here is a 1. Now, they didn't use an x, but you understand it doesn't matter that they don't use x. They could have used
it's still a variable.
Yeah, a variable, as long as it's a variable. Yeah. If the a value is 1 and the c value is 0, then you should be able to do this within 10 seconds. Yeah? Instead of 5 minutes. Yeah? Not that I'm trying to make you rush, I'm just trying to show you tricks that'll make it easier for you. Yeah? But if you don't see it on a test, then that's where have you ever noticed sometimes some problems take longer than others? You know? But if you remember some of these tricks, the only way you're going to remember these tricks is if you practice different types of problems. Yeah? So that's why those ones I gave you, I wanted to make sure you understand how to do this. Okay? Does everybody see that I did quadratic equation and I did factoring? Obviously, factoring was very, very quick and to the point. It's not always going to be that case, though. Okay? Sometimes some of the factoring might take longer because maybe some of the numbers that we're trying to figure out that multiply, give me the top and give me the bottom, we can't figure it out. Remember, there is also other ways that you're going to be able to do all these solutions, zeros, roots, and x-intercepts. Another one is called completing the square. I'll go through that one, not right now. I'll bring it up again later. Okay? Go ahead.
What happened to the k that was in front of the 8?
The k,
How can that one cancels out?
this one right here. Right here.
No, the k in front of the 8. Like,
Right here.
I understand that there should be 2 k's right there because of the k squared, but what happened to the k that's
In front of the negative 8.
behind the 8? Yeah.
Okay. If I distribute it back in, k times k is k squared, isn't it? And when I distribute it over here, negative 8 times k is the negative 8k. All right. When you're factoring out, you haven't made it disappear. You're just rewriting it. Kind of like, for example, if I were to say factor out 64, you can factor out 64 a couple different ways. You can say 8 times 8 Yes, it's 64. But you could also say 32 times what? 2 is 64. Now to figure out all the different ways, I would just do the factor tree of 64. And you see all those numbers that I circled out? Factor tree, if you don't understand how to do factor tree, you're going to need to remember how to do that, because when you guys start working with radicals and when we get into the trigonometric functions that we have to do in graph, you're going to have to write radicals in simple radical form, not in decimal form. So you're going to need to remember how to do square roots and simplified square roots. So does everybody see this factor tree that I did right here? That factor tree, you guys learned how to do that in algebra. Okay. 64 is the same as saying 2 to the 6th power, which means you need to know your rules of exponents. And you need to remember that the rules of exponents are going to start to pop up, which means some exponents can be negative. Okay? Does everybody have the piece of graph paper that I gave you guys last time? Yeah? Can you pull out that piece of graph paper? I want you to add something to it. I want to go over the rules of exponents. Exponents are going to come up in this unit. So this is your quick review of exponents. So do me a favor. In your graph paper, we're going to need some space, okay? So just do me a favor, draw a line wherever you finished off last, so that way you don't mix up the rules of exponents with what we're about to do, okay? Do you have graph paper? Yeah. Probably. All right, make sure you have enough room. All right, just let me set it up real quick. Let me set it up real quick so you can find out where you're going to fit it in your page. Make sure you write down rules of exponents. Okay. So I'm going to start off with okay, go ahead and write that down for me. So I used an example right now, and I said, well, what if x is 2? If x is 2 in this example, that would be 1 over 2 to the third, which is 1 over those multiplications of 2. So do you understand where that 8's coming from? Yeah? All right, so the next one is x to the minus 2, which is 1 over x to the positive 2, which is 1 over x times x. You need me to show you an example for that? You understand you can pick any number. Let's do one example just to make sure. Let's do a negative 3. Because I want to show you what happens with the negative numbers. Okay? So whenever I put IE like that, that means in example, this is what I mean by that, yeah? Well, that's 1x is, oh, let me write it as a -3 to the -2 power. That's what I was forgetting last time, was to write it like that. So what I was trying to do over here was 1/8 is the same as saying 2 to the -3 power. That's what I forgot to write down. 2 to the -3 power is the same as saying 1/8. Okay? Now, do you understand 2 to the -3 is 1/2 to the +3? Okay. Now, what happens if you got a negative number? -3 to the -2 power is 1/3. The -3, that base does not change signs. Only the exponent does. Okay? And that's really 1/3 times a -3, which will be 1/9. So I gave you an example with a negative number. Let's stop right there and just make sure I'm not doing something that you're kind of like, whoa, what the heck did you just do? All right. Does this make sense so far?
And for the first one, shouldn't you have put 1/x to the -3?
Good question. I'm glad you noticed that. X to the -3 is what I wrote originally, right? When I rewrote it, I wrote it as 1/x to the +3. What I want you to notice is x to the -3 is really written like this. Over 1. Any number that's not written as a fraction is always written over 1. Top is the numerator, bottom is the denominator, right? Here's the rule with negative exponents, okay? Whenever you have negative exponents,
You have to flip.
you have to simplify it and put it with positive exponents. So let me prove this to you. Everybody grab your calculators. Everybody grab your calculators. Where's mine? Here's mine. All right, everybody turn on your calculators. All right. Clear that. All right. Remember I just did the number, was it 2? Let me check. I just did the number 1/2 to the 3rd power, which is really the same as saying 2 to the -3 power, right? Okay. With your graphing calculator, do me a favor, type in 2, raise it to the -3 power, but use this minus sign right there. Go ahead and hit enter. And we get 0.125, right?
Where would be negative?
If 2 to the -3, you think it should be negative? Only if it would have been this way, I think, is what you're thinking. That would have made it negative, yeah? The base, if the base is negative and the exponent is an odd power, yeah, it would be negative, yeah? Now do me a favor, check. Do 1 divided by 8. You see we get the same number, 0.125. All right, do me a favor, and I now type in -3. So you're going to have to use a parentheses, -3. Raise that to the -2 power. Now we already did -3 to the -2 power, right? Go ahead and hit enter. point 1 never ends, yeah? Do me a favor, do 1 divided by 9. Okay, you with me so far? Okay. The rules of exponents, if the exponent is a negative, you have to rewrite it, okay? Now, the question that you asked me, do you notice that the base had a negative exponent on the numerator side? That means it needs to move to the denominator, and then that exponent becomes a positive. If this would have happened, if I would have had 1 over x to the minus 3, but notice it's on the bottom right now with a negative exponent, and go the opposite way. If it's on the bottom with a negative exponent, move it to the top. On the bottom, only whatever's left that has positive exponents stays there. If nothing is left there, it's because it's a 1. Okay? So let me prove this to you. What if I had 1 over 2 to the minus 3 power? All right? I'm going to prove to you that that is the same as saying 2 to the positive 3 power. Okay? So we'll go ahead and grab your calculators again. Because these are very good questions. Now we're going to type in this one right here. We're going to type this one into the calculator. So we got to be careful how we type it, okay? We are going to have to put a parenthesis. So we're going to do 1 divided by, and right there we're going to put a parenthesis, and we're going to write 2 to the minus 3 power. Get out of the exponent right there, because if you put the parentheses right now, that might mess it up. Does everybody see how I wrote that right now?
You don't put the parentheses over the 2 and then the exponent inside.
Try it. Try it. Parentheses usually are going to help you to isolate, numerators and denominators. There's a couple ways we could have done this. We could have put a bunch of parentheses to help us. All right. But technically, what I just typed into the graphic calculator is the same as what I have right here. Yeah? With me? Okay. Go ahead and hit enter. Notice I got a positive 8. Okay, do me a favor, type in 2 to the 3 power. Notice I get a positive 8. You agree that 2 to the 3rd power is just 2 times 2 times 2, which is 8. This one is really 1 over 2 to the negative 3 power, but because it's a negative, you can't leave it like that. You have to rewrite it as 2 to the positive 3 power, but notice on the bottom there's nothing else there that has negative exponents. That's really a 1. Okay. So do you see that these two, both of these two written are the exact same value? 8? Alright, so does that answer your question? Because this is really important that you understand that rule. If it was on the bottom with a negative exponent, you need to move that base to the top and write it as a positive exponent. Okay? If it's on the top with a negative exponent, then you write it on the bottom as a negative exponent. Okay? So did I prove it to you that those two were the exact same thing? Yeah? Okay. All right, so now the next one then would be written as what? First power. 1 over x to the first power is the same as just saying 1 over x. Yes? Okay. X to the 0 power.
Doesn't do anything, does it?
Ah, it does. Times of 1. Go to your calculator. do 9 to the 0 power. Figure it out. 1. Let's do this. Let's do x to the 0 power. See what it do. We'll throw it out. Give me the right answer.
Mine went to some type of error domain thing. Maybe I typed it in wrong.
Maybe you typed it in wrong. How about 0? Let's try 0 to the 0 power.
Yeah, it just says error.
0 to the 0 power is error because 0 to the 0 power you can't do. It's just 0. Yeah? That's the only exception, that anything to the 0 power is equal to 1. 0 to the 0 power is not equal to 1. Because if you could prove that, then you could become so filthy rich. If you could prove that 0 to the 0 power equals 1, you would just blow everybody's mind. If you could prove that. Because now you're making magic. Because I have nothing in my hands right now. And you're saying I have nothing and I raise it to no power. Now, bam, I got one thing. That's magic. Yeah? Does that make sense? So 0 to the 0 power, that's why it goes to there. Because you can't do it. It doesn't equal 1. Yeah? If I notice when I did x to the 0, it still gave me 1. Any letter to the 0 power, as long as the letter is not 0. Yeah? What if I do this? -2. Oops. That's going to mess everything up. -2 to the 0 power. Now that's a negative number. Still equals 1. Well, that means I can you can pick any number. You can pick a fraction. You can pick a square root. Yeah. All right. So far, does everybody believe anything to the 0 power except for 0? Anything else to the 0 power will always equal 1. Yeah. You got to remember that rule, though. Okay. All right. All right. So right here, x to the 0 power, and here's why it's 1. Okay. It's because you have the base divided by the base itself. Anything divided by itself is always equal to 1. Okay? X to the first power, does everybody agree x to the first power is just x? Okay. X to the second power, well, that's just x times x. Yeah? X to the third power is x times x times x. X to the fourth power is x times x times x times x. Ooh, I threw one out actually that looks like a fraction. That's really x to the fifth power, which is x times x times x times x times x. And then this one is really 6. Now, I'm not going to write out all those x's. But I do want to show you something. What is x then to the 1/2? Notice I didn't do any fractions. I just did all the negatives, 0, and the positives, right? Those aren't the only numbers that are in our real world, right? X to the 1/2 power, well, let's figure out a number. What do you think? Pick a number. Pick a number, right? 5. All right, everybody go to the calculator and type 5 to the 1/2 power. We're going to have to put a 5 in parentheses, and we're going to raise it to a power in parentheses of 1 divided by 2. All right, so look at how I typed it in. All right, go ahead and hit enter. See what you get. Probably going to be a decimal. Now, you don't probably see it right now. I'm sure, I'm assuming that's what you got, yeah? Yes? Okay, let me show you something. How about 4 to the 1/2 power? Go ahead and type 4 to the 1/2 power. See if it works when I do it without the on either, I can do it still?
Yeah, that's what it
Okay, so let's try it. I just don't want to, I want to avoid making errors. Okay, that's right. I would assume sometimes just be careful though, because remember the calculator is only as good as the person that uses it. I try to use parentheses as much as I can so I don't mess up. Yeah. 4 to the 1/2 power, that's 2. What do you think 1/2 power is then? 1/2 power is the same as square root. Do 9 to the 1/2 power to check. You already know the square root of 9 is, right? Do 9 to the 1/2 power, see if it works. Does it give you 3? Do you remember whenever you got to this point, let's say x squared equals to 100, how would you solve that equation for x? Square root both sides, wouldn't you? What's the square root of x squared? X. What's the square root of 100? Okay. Actually, it's plus or minus 10, isn't it? Yeah. You see why that's in the quadratic formula? Remember the question you asked me, why is there a plus or minus there? Remember when you did the square root of a number? It's because those two numbers could be 10 times 10 or negative 10 times negative 10. Don't both of those give you positive 100? Yeah. So do you see why the quadratic formula has the plus or minus and why there's going to be possibly two answers? Yeah. It's because when we take square roots, we didn't know if they were both positive or if they were both negative. That's why that's in there. That makes sense? So do you see that raising something to the fraction of 1/2 is the same as saying, well, where's my square root of? Square root of 9 is, right, 2 different ways to write it. Yeah. Square root and squaring are opposites of each other. Yeah. Check this out. Square roots and squaring are opposites of each other, right? So if I'm going to do the square root of both sides, that'll solve it, right? What if I do this? Instead of square root, I raise it to the 1/2 power. What happens when you raise an exponent to another exponent? Multiply them. What's 2 times 1/2? Yeah? And that just becomes x. And 100 to the 1/2 power is basically just square root of 100. So you see squaring and the fraction form of it are opposites of each other. So keep this in mind. What if I had something that was x to the 3rd power equal to 100? That would be the 1/3 power is the opposite of to the 3rd power. What's 3 times 1/3? 3 over 3, which is 1. X is equal to, well, I don't even know what that 100 to the 1/3 power is. You can type it in. 100 to the 1/3 power. It's going to be a decimal. 4.64, yeah? Does that mean that those are the only types of fractions I can use? You could make up some ridiculous fraction. as long as the denominator is never 0. Math can go forever. So that's why our technology keeps getting better. Because people are still learning how to put all the math together. The only reason why this smartboard is the way it is because of the math equations that are used to set this up. Just like a computer program is programmed. Just like your cell phones. All these cool apps and all that stuff, those are all math problems that are inputted into the program.
Computers used to communicate in zeros and ones.
They still do.
Oh, they still do?
That's called the binary system right there. Everybody see this binary system right here? This is how your cell phones are done. This is how your checking accounts are done. This is how anything that involves any kind of security code is done in this system called the binary system. And you know that the binary system is based off of exponents? So those zeros and ones are just based off of 2 to the 0 power, 2 to this power, this power, this power. Why do you think they didn't use 1?
Because one times anything is one.
One times itself, a billion times, is still going to be 1, isn't it? And you understand why they didn't use 0? Because 0 to the 0 power doesn't exist. And then after that, 0 to the first is 0. 0 to the third would be 0. Here's why this is used with the base of 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. Okay. Do you notice right now it has nothing but zeros there? If I were to change that, then the security code for that specific either credit card, bank account, or cell phone, or whatever may be using this security code, has a security code. And here's the thing, there's only, watch, I'll write this out. And it'll be kind of weird, but I don't mind going this way right now. Correct me if I'm using the wrong there, because I always do this. I want to say there are only, so T-H-E-R-E?
Yeah.
Okay. Remember, English is not much to consider, okay? There are only okay, read it to yourself what that says. Okay, what do you think it says, Yvette?
There are only 10 types of people.
Okay, what do you think it says?
There are only 10 types of
Yeah?
people.
Same thing?
There are only 10 types of people.
Yeah? Yeah?
Yeah.
It really says this. There are only 2 types of people. Those that can read binary and those that can't.
Oh.
Does that make sense?
I get it.
Do you see that the 1 is right above 2 to the first power? 2 to the first power is 2. Notice nothing else has a 1 over it. So then that means 2 plus everything else is just 2. That says there's only 2 types of people in this world. Those that can read this binary system and those that can't. And most people don't know how to read it. And in math, that's how you get security with that system, the binary system. All of your bank accounts that you will ever have, all of your credit cards that you will ever have, any type of cell phone that you have is based off of that system, the binary system. Next time you see something on the TV that is involving money, you're always going to see zeros and ones in the background. You ever see the movie The Matrix? Those are all zeros and ones because those are codes for something. Yeah? And that's what those... did you bring up binary? Who brought up binary?
I think I was.
Yeah? Somebody said binary, so that's why I went off of that. But do you understand binary is based off the rules of exponent stuff? These rules of exponents. So binary goes from 2 to the 0 all the way from 2 to the,
Oh, yeah, no, I said, is that why computers communicate in zeros and ones?
because of the, okay, zeros and ones are called the binary system. So the next time you see this, there are only 10 types of people. It's not saying 10 types of people. It's binary code to say that there's only 2 types of people. Those of you that can't read this, and those of you that know how to read it. Okay? That binary code determines everything you do with electronics. Anything that involves any type of security electronically, it goes off of that system. Now you notice I only have 2 to the 5th power. That doesn't end. It just keeps going all the way to 2 to the 1,000,000th power. Most of you guys, when you guys have security codes, they're either 8 digits long, right? And they're either letters or numbers. Yeah. And everything is based off of that, because from there we can use, however many letters are in our alphabet. But remember, we're not the only country that has an alphabet, right? The alphabet in Mexico is not the same as the alphabet in the US, only by a few letters. But then you gotta remember the alphabet in China, yeah? The alphabet in Arabic, all the other languages. The only way we can communicate with each other is through these zeros and ones, because 0 is 0 anywhere in the world. 1 is 1 in China, in Arab, anywhere in the Arabic countries, anywhere in Middle East, anywhere. Zeros and ones are not different. Math is the same everywhere. So when you speak math, the language of math, that's another language actually. That's what all these computers do. Yeah. Right. So do you guys understand these rules of exponents? Because then they're going to come up. Okay. We're going to start to get into some trickier stuff, but do you guys have your notes here? X to the 6th power. Yeah? Just that multiplication of that number by itself 6 times. Yeah? That's algebra, wasn't it? Okay. Put this in your notes, though, too. Because the fractions. Yeah? Fractions are there. And now we went over, I proved to you how, I don't know what I was trying to do. Oh, okay. Okay. 100 to the 1/3 power was 4.64. If I were to raise that number to the 3rd power, I'm just going to say, oops, I'm going to raise the answer that I just got. I'm going to raise that answer to the 3rd power. You see, I go back to 100. And the reason why is, when you multiply 4.641588834 by itself 3 times, it's the same as going backwards of 100 to the 1/3 power. So here's why I love math. Whatever you do in math, if you do something wrong in it, it'll mess up. So if you don't balance it out ever, math always has to be balanced. Whatever you do to one side, you got to do it to the other side. And that's the beauty of math. It can never be unfair. And I've grown up with a lot of things done unfairly to me, but with math, it's never unfair. And that's the thing about math. That's why I love it so much. Is it can't be unfair with it. It's always fair. It doesn't, its language is itself, and its language is based off of any country you go to. They're gonna know what you're saying right now. Yeah? Okay. Now, do you guys understand our number system and our letter system, our ABCs? that's not how everybody uses. The number 1 is written in different ways in different countries, but 1 still means 1 with 1 marking. Even in Egypt, when they were carving in the hieroglyphics, 1 image, that was 1. Yeah. 0 still was 0. I remember in college I did a paper on the number 0. You know, it was about this big. You know, all about the number 0. And you think, how much could you say about the number 0? Man, there's so much. Like, I typed a bunch of pages about the number 0. You know. Yes, I did give you a paper. I did it. And I presented it. I wish I had my presentation, so I think I might have it. You know. And all I did was talk about the number 0. And it went back way far. Just, you know. And that's stuff, this is why I like math. To me, it's, you guys see the drawing right there, that's math to me. Even though it's kind of like a stained glass drawing, but it's math. I don't know if you see the math in it. Some of you guys remember drawing and getting all the designs for it.
There's a lot of geometric shapes.
Yeah. Everybody that was in my geometry class, DeAndre and you guys were here when that started. Yeah. And we went off of your guys' designs. Remember that? Yeah. And then the next geometry class is going to add to it, to the sides. So you guys, those of you guys that were here, that was all of you guys putting that design. And then you guys did it. Now the next class is going to be the outsides of it for the 2 windows. And then the next year, the next geometry class will be the outside. You guys, for algebra 2, I'm going to use that one. We'll try to figure something out. Yeah? Okay? And hopefully it stays. And then that way you can be like, look, I was participating. And I try to keep people's stuff as much as I can all over the place, as people do stuff. And I have yours somewhere. I think I had it somewhere. I'll do a little more, I think. But I keep those things, especially the really, really big ones. Remember, guys, when we did that one? The golden ratio? Yeah. Those of you that I didn't have in geometry, it's just the people I did have, we did all these other things. All right, so rules of exponents. You guys understand this is going to come up in this unit. Okay. All right. So factoring. Those were the types of answers you got. So I'm gonna make sure. Yeah. So if for some reason you didn't get to check your answers on the factoring, I'm putting it on the video right now. So numbers 1 through 8 are up on the video. For some reason, if you don't get a chance to check them right now, or you didn't finish them, check your answers. Okay, I know you forgot yours, so just go back and check the video on that. There's numbers 9 and 10. Okay. Now, the answers are there. I'm always going to give you the answers, but it's, do you know how to get to them? That's the key. So don't just assume, oh, I got the answers. Man, I'm always going to give you the answers. Even when I mess up. You guys are going to help me figure out what I did wrong. Yeah? And most of the times, you guys have caught stuff sometimes that I don't see. Eric, you caught something that I didn't see. And sometimes it's because I got to step out from what I'm doing. You guys are looking things differently, sitting down. Yeah? So I don't see everything all the time. Okay? Numbers 11 through 18 are right there. So what you'll do is pause the video at any time to see what those answers are. Okay? And just check them. Okay, so those are going to be posted up and this will be for unit. We're on unit 2, and this will be day 2 video. Okay? All right. So let's go to the next part then. I want to get to this part right here. Does everybody have this handout? Can you guys do me a favor? Can you type in that equation that says f of x equals 1 over x to the third? And I'll give you a hint, that's really x to the minus 3 power. If you were to type it in on the graphing calculator, it's going to graph the exact same thing. So do you understand the exponent rules now? If I graph y equals x to the minus third, it's the same as graphing y equals x to the 1 over x to the 3. Those are the same. So I'm going to go ahead and type mine in. And when I turn it on, I'm going to go hit the y equals button. I'm going to clear that, and I'm going to type in x to the minus 3 power. Oops, that's. Delete that. Graphic. Zoom up. You guys getting the hang of how to work with this calculator and zoom to fit it. See if it'll look nicer. No, I don't like that. I'm going to zoom in. Okay, if I were to keep hitting enter, it would just keep zooming in. All right, does everybody see that the graph goes like this? Everybody agree? Graph goes like that? Now it says I investigate the function, so this is a odd number function with a denominator. It does have points that are errors on the graphing calculator. So if you were to pull up the table of values on the graphing calculator, there's an arrow when x is 0. When x is 0, oops, I'm going to change colors here. Highlight it. When x is 0, that's really the y-axis. There's an error there. And you understand that that error means that graph will never touch the y-axis when x is 0. Now you would state that when x is equal to 0, there's an asymptote. When y is equal to 0, there's also an asymptote. When y is equal to 0, there's an asymptote there. Am I using the right there in this case? Yeah? All right, I'm going to trust that you guys are checking. Yeah? All right, so does everybody understand why the green line is y equals 0? That is the x-axis. But if you were to graph y equals 0, it's the whole x-axis. And if you were to graph x equals 0, that's really the y-axis. And it sounds kind of weird. But it's because you're graphing at x equals 0, everything that goes up through that point. Okay? So there are asymptotes. Odd degree function as a fraction. Yeah. Now, there are going to be times that we're going to get, there are going to be times that sometimes there might be, there are going to be times that the graphs have holes in them. Not that this one does. There's going to be times where there's points of discontinuity. And points of discontinuity is when there's breaks in the graph. This one doesn't have that. Okay? But when there's points in the graph, that's points that are not part of the graph. Okay? So those will be open circles. Okay? They'll be breaks. So I just wanted to point that out. This graph, though, does not have any points of discussion. Okay? Everybody okay with, you guys understand how to input graphs into equations? Yeah. Keep in mind, I don't know if anybody in here has done this, but f of x is the same as saying 1. It's also the same as saying 0 equals x minus 3. Those three things can be used interchangeably, as long as 0 is on one side by itself. If you have, let's say, 0 plus 3, you got to move that plus 3 to the other side. Okay. All right. Any questions right there on that? All right. Number 5 and 6. Solve the equation. Do you guys understand that means find the zeros, the roots, the x-intercepts, or the solutions? Basically what we were just going over earlier with the quadratic equation or the factoring. So on numbers 5 and 6, I'm going to leave those for you guys to finish 5 and 6 on your own. Is everybody okay with that? Yeah? Okay. Let's go to number 7. It says, solve this problem for x and clearly show your solution. I'm going to get to problems like this in the next class, okay? For today, I'm going to skip that one because the next class, we're going to do some problems that are going to involve solving these types of fractions. All right? And then, but I'll give you a hint here on this one. Cross multiply to solve it. Isolate the variable, okay? I'm going to skip that one because that one should have been something you saw back in algebra before. Okay. I'm going to skip that one. Choose a variety of values for h in the function y equals a plus parentheses x plus h squared plus k, and explain how the different value changes the function. Be sure to use graphs as part of your explanation. Let's go to this one right here. So first thing I want to do is I want everybody to write this down. Y equals x squared. Everybody graph y equals x squared on your graph calculator. Do that. Y equals x squared. My graph looks a little funny, and that's because my window is got different increments on the x and different increments on the y. So an easy way to fix that is zoom it into the standard 6. Okay, 6. That shows increments of 1s on the x and increments of 1s on the y. Is that what your graph looks like? Yeah. All right. Do me a favor, draw a rough sketch of it underneath. Everybody agree it goes through the x-axis and the y-axis at the origin? And it just opens up here. All right, right next to it, can you do this? Write y equals negative x squared. What do you think? By just putting in that negative, what did it do to it?
It's going to shift it down.
Shift it down. Go and check, make sure that that's what happens. So go back to your y equals, type negative x squared. Make sure that All right, my graph shows that it does go down. So go ahead and draw a sketch of that. Now this is called the original parent function. Remember those handouts I gave you guys with the parent function? Yeah. That's the original, just y equals x squared parabola, okay? The minute you change the a value, if a is equal to a negative, if a is equal to a negative, that's what happens. Yeah? What do you think would happen if I made the a value a number like 100? And I said y equals 100 x squared. Not sure? Type it in. Look at it. Go to y equals, clear that, type y equals 100 x squared. Got that. Do you see that the graph is really in there? But you can't really see it clearly, right? Go ahead and zoom and fit it so that the tables change to adjust to whatever the graph is. What did 100 do to the graph, you think? Go together? And here's how you can check. Everybody go to the table of values. When x is 0, y is 0. When x is 1, y is 100. So do you notice in the original parent function, when x was 1, y was 1? And when x was 2, y was 4? Do you see that it's making the graph way tighter? What do you think would happen if I were to use a fraction? Try a fraction. Go back. It's going to make it wider. Clear it. You might have to use a parentheses here. 1 divided by 5, I'm going to say. X squared. Now right now, it's set in the table of values from the last graph, so I'm going to have to go back and zoom it to fit what it looks like now. Or you can hit zoom standard. You notice that the original graph, and I'll type the original one right underneath it. Go ahead and type in, oops. Type in the original one right underneath it, y equals x squared. Does everybody see that the fraction is going to start to widen it? There will be a point that you can only make it so wide though. Yeah? You can't make it a flat line. A parabola has to, remember how math is fair? In parabolas, there has to be an opposite on the other side, like a reflection point. Yeah? There will be a point where that fraction looks like it's going to get to touch the x-axis, but that's just because you widen it so much. Yeah? All right. So do you guys see if the a value is greater than 1? If a is greater than 1, the parabola gets narrower. If a is less than 0, or I'm sorry, no. If a is greater than 0, but less than 1, So if a is greater than 0 but less than 1, we can write it like this, put together. If a is greater than 0 but less than 1, that means it's going to be a fraction. Then parabola gets wider. So do you notice we haven't done anything yet? We haven't done all the other parts of the quadratic formula equation, y equals ax squared plus bx and then plus c, you know? Now let's type in this. Y equals 1 times x plus 2 squared. Go ahead and type that into the graphing calculator. Y equals 1 parentheses x plus 2 squared. So go ahead and delete the 2 that we've already done. You can, if you want to leave on y2 the original parent function, just y equals x squared, leave that on y2. Yeah? So on the top, we're going to type in 1 parentheses x plus 2, close it, and raise it to the second column. Is everybody okay on the typing with that? Yeah? Let's go ahead and graph that. All right, does everybody understand which one is the original? Right at the origin. Okay. What happened when I did x plus 2? Moved it to the left. What do you think would have happened had I done x minus 2? It would have moved to the right. You notice that's opposites of the plus 2? And here's why. It's because you got to let x plus 2 equals 0. Solve it for x. And the x-intercept is at negative 2. Okay? You guys see that? A value is 1, right? If the a value is negative, then the parabola goes down. What if the a value is greater than 1? Parabola will get down. If the a value is a fraction, then the parabola will get wider. So then this part is if h, or I'm sorry, if h, so y equals a x plus h squared plus k. H value shifts the parabola which direction? Which way did it? To the left or to the right, depending on what's written inside of it. So H value shifts the parabola to the left or right, depending on the value. Ready to understand that part? So if this would have said x minus 3, which direction would it shift? If it would have said x minus 3, to the right, how far? 3 units. So whatever the original is, move it to the right 3 units. If the a value is 1, the parabola didn't shrink or get wider. Just shift it to the right 3 units. Does that make sense? All right. So then what do you think if I were to do this? Y equals, let's do y equals 1, x plus 2. Or no, not x plus 2, let's change. Let's do x minus 3 squared, and then let's do minus 2. So go ahead and type that into the graphing calculator, the one that is red, okay? Now go ahead and delete the one that we're working on right now. Still leave the parent function though there. Do I need to write 1 in the graphing calculator? No, unless it's a negative, yeah. But if it's a number greater than 1, yeah. But you can actually just put the parentheses x minus 3, square it, and then get out of the squaring and then make minus 2. Notice right there I didn't put the 1 in the graphing calculator in front of the parentheses. That 1 isn't going to change it. Okay? Go ahead and graph that. You guys notice the parabola is in a different spot compared to the original function? So the graph shifted which direction, left or right first? Right? How much? Right 3 units, and then down 2. Does that make sense? Shifted to the right 3, and then down 2. That's where the vertex should be. If the a value would be a negative, it would just flip that parabola. If the a value is greater than 1, it's going to make the parabola narrower. If it's a fraction, it's going to make it wider. Okay? So here, that k value, so the k value shifts the parabola up or down, depending on the value. So, do you see that you guys can basically graph these equations without even really using the calculator? Yeah. Now, what if you have to factor them out, and you have to do quadratic equation and find the x-intercepts? Because this is when I show you how to write a quadratic like this, that's when we start doing what is called completing this. Okay. Now, I'm going to show you something real quick. All right. And just, you guys go ahead and put your pencils down, just relax. Okay? I want to show you something. Here is that equation that I just wrote, yeah? So just watch. I'm going to rewrite that equation in what is called standard form. Or better yet, I challenge you. I'll give you a 1-minute head start. Let's see if you can get to it before I do. I'll give you 1-minute head start. 1-minute head start. See if you can write that equation in what is called standard form. So you got 1-minute head start on me. I'll show you algebraically, but there's different ways you can do this. You can look at the graph. You can look at, there's several ways you can do this pretty quickly, okay? You try to do it however way you think you can do it. You got 30 seconds head start on these two, okay? I'm going to do it the long way first, so that way you got some extra time ahead of you, okay? You got 10 seconds ahead of you. All right. My turn. right, I'm done. Okay, that's in standard format. Okay, now just take a look at what I did. Does it make sense what I did?
Wait, why'd you get 6x to the 7? Is that a 7?
It's a 7. Okay, did I mess up?
Why is it a 7?
No, and there's 7 as an exponent.
Okay. First, let's check, is my FOIL method correct?
Isn't it?
X times x squared?
Yeah.
All right, x times negative 3x. Okay, then another negative 3x, and then a positive 9. Yeah?
Yeah.
Notice the negative 2 was on the
I
outside.
know, but why is it x to the 7?
Oh!
Yeah.
Yes,
That's what
that is
I
wrong.
know that.
Thank you. That part wrong. That part is wrong. So you did correct me. I got too happy there. I got happy because I saw that 7 and I was put a 7 there, so you fixed it. That one was wrong because of that. That 2, I wrote a 7 there, so that you are correct. Other than that, anything else? Mistakes? I was just trying to beat you. Right, did you see what I did? I just did the FOIL method on the x minus 3 squared part. And then after that, you notice the negative 2, I just brought it down, and then after I simplified it, I combined like term. All right. Could you go from here back to that if I gave it to you? No? That's what I'm going to teach you when we do completers. Could you factor this? Could you tell me the 2 parentheses that multiply to give you that?
Well, can you factor it out?
You can try to do the Xbox method. Now, I'll just give you a hint. A value is 1. 7 times 1 is 7. What two numbers multiply to give you 7, but add to give you negative 6? The only options I see are negative 7 times a negative 1 gives me a positive 7, doesn't it? But when I add them, I get a negative 8. I need to get a negative 6. Negative 6 plus negative 6 times 1, though, is negative 6.
Go to negative
And
Wait,
negative
you're supposed to multiply to get to negative 6 and add to get to 7.
A value is 1, C value is 7, right? So when you do the Xbox method, you multiply the A times the C. So that's why the top is 7 on the X. 7x squared. And the middle term is the minus 6, 7. So I need two numbers that multiply to give me 7.
Oh.
But add to give me negative 6. And I have a feeling that the numbers are decimals. So if I get to this point, first thing I'm going to do is this. Do I know what A, B, and C are? A is 1. B is negative 6. And C is 7. Alright. So what I just did is I looked at the problem and I said, alright, I honestly don't feel that there's two numbers that multiply to give you 7 to add to give you negative 6. So, and I tried a couple of options. I could have tried negative 7 times positive 1. If I did negative 7 times positive 1, that gives me a negative 7. I don't want a negative 7, I want a positive 7. Yeah? Because negative 7 plus positive 1 gives me the negative 6 that I'm looking for. But it's almost there, but I can't use that though. Yeah. So let's simplify this. That's positive 6 plus or minus 36 negatives. What's 4 times 7?
28.
All of it over 2. 6 plus or minus 36 minus 28 is 8. And square root of 8, you guys see that's going to be a decimal? Yeah. Do you need a decimal value you get from square root of 8?
2.
Okay, we'll just use 2.8. That's why I couldn't factor this, because I'm going to get a decimal from my x-intercepts. Yeah. So the two x-intercepts are at x equals 6 plus 2.82 divided by 2, and 6 minus 2.82 divided by 2. And I'll give you a hint. If I were to type that into the equation, actually, I don't even have to type it. I already typed it in here. Does everybody see the x-intercepts approximate? If I hit the trace button, somewhere between 1.4 and 1.7 is an x-intercept. Somewhere between them. I don't have the exact value, but yeah. The exact value is right here. 6 plus. Now, even that is not even exact, actually, because I'm saying I'm already estimating 2.82 because it was 2.82 some other numbers. So I'm already estimating, so that means I'm already off a little bit. Okay. But if you do 6 plus 2.82, that's 8.82. And 8.82 divided by 2 is going to be 4.41, or 8.82 divided by 2 would be 4 point something. Is that right? Okay, 4.41. That means one of the x-intercepts is at 4.41. You see that's over here. Somewhere at 4.41. And this one over here is the one that's the 1.4 something. That one's going to be 4.82 divided by 2. Yeah. So you guys starting to see how you can do all types of different ways? There isn't just one way to figure this out. Yeah. Do you notice that I stopped trying to do the factoring right here? I stopped trying to do the factoring because I couldn't find the two numbers that multiplied to give me the top but had to give me the bottom. If you get stuck right there, here's a hint. If the A value is 1 and whatever the C value is, just multiply those two together in your head. Can you find the two numbers that multiply to give you that but add to give you this? If you can't, then go to the quadratic, because you're gonna probably be beating your head on the push to try to figure it out. If you can't do it within a minute, just go right through the quadratic. Because there's a good chance they can't even factor it. You can't factor it because the answers are decimals. And you guys have never really been taught how to work with decimals to multiply to give you a certain value. And that's okay. All right. Any questions there? No? Okay. So, in closing, I want to make sure you guys are going to finish 5 and 6, yes? Okay. You guys should be able to match the rule that matches with those functions right there, yeah? On the benchmark? Okay. We'll go over those differences. Okay, this is what I want to start doing next, is how do you find the asymptotes of the equations, okay? Let's go ahead and clean up. Make sure you guys tuck in your chairs. Please take any of your stuff because I got a class coming in right after you. There you go.